You've seen them parked at the edge of every major airport runway. Lime green, massive, sitting there doing absolutely nothing. Most people assume they're just a precaution, a formality, something airports are required to have but rarely need. That assumption is wrong. Those trucks are not waiting for something unlikely. They are positioned there because every single commercial flight is considered an active emergency risk from the moment wheels leave the ground to the moment they touch back down. And if something goes wrong, those machines have a window of roughly 90 seconds to prevent a survivable accident from becoming something else entirely. The vehicle is called an Aircraft Rescue and Firefighting truck, or ARFF for short. The most common model in the United States is the Oshkosh Striker, and it looks like nothing else on the road. It weighs up to 44 tons. It carries up to 4,500 gallons of water and 600 gallons of firefighting foam concentrate. It has turrets mounted on the bumper, the roof, and in some configurations, a 65-foot extendable boom on top. It is not a fire truck in any way you are used to thinking about one. It is a mobile suppression platform engineered for a single environment where fires burn faster, spread wider, and kill quicker than almost anywhere else on Earth. Here is the thing most people do not understand about aircraft fires. You cannot fight them with water, not the way you would a house fire. Jet fuel, which is essentially highly refined kerosene, floats on water. If you spray water onto a burning fuel spill, the fuel rides the water outward in every direction, and the fire expands rather than contracts. You have made it worse. This is why every ARFF truck carries foam, not water, as its primary agent. The foam used is called aqueous film-forming foam, a compound originally developed by the United States Navy in the 1960s, specifically because shipboard jet fuel fires were destroying carriers. It works by laying a thin film across the surface of the burning fuel, cutting off oxygen contact and stopping the fire from reigniting. A jet fuel fire goes out the same way it started, through chemistry, not volume. Now here is where the clock matters. A commercial aircraft carries tens of thousands of pounds of fuel. A fully loaded Boeing 737 holds roughly 26,000 pounds of jet fuel distributed across tanks built into the wings. In a runway accident, that fuel does not stay inside the tanks. It spills, it ignites, and it spreads along the surface of the runway in seconds. Studies have consistently shown that survivable aircraft accidents become fatal when fire reaches the fuselage. The structural integrity of an aluminum airframe begins to degrade in under 2 minutes of direct flame contact. This is not a theoretical margin. It is the specific engineering reason why the FAA mandates by federal regulation that at least one ARFF vehicle must reach the midpoint of the farthest runway and begin agent application within 3 minutes of the alarm. Not 3 minutes to arrive. 3 minutes to arrive and start spraying. To understand what that 3-minute rule requires, look at what the Oshkosh Striker is built to do. Its 700 horsepower V8 diesel engine must accelerate the 44-ton vehicle from a standing stop to 50 miles per hour in under 25 seconds. For comparison, a standard 40-ton semi-trailer takes more than a minute to reach 50 miles per hour. The Striker does it in under half that. The entire chassis is engineered around this single requirement: lower center of gravity to prevent rollovers at speed, independent suspension on all wheels for off-road access across grass and unpaved aprons, rear wheel steering on larger models to cut turning radius on a vehicle wider than most lanes. The truck is fast, not because speed is impressive, but because the runway is long and the time window is measured in seconds. There is one more piece of engineering that most people never consider. A standard fire truck stops, sets up, and then fights the fire. An ARFF truck cannot do that. A fuel spill fire moves across the surface of the runway as the fuel spreads, and a stationary truck would be fighting yesterday's location within seconds of arriving. This is why ARFF vehicles are built with what is called pump and roll capability. The same single engine that drives the truck also powers the water pump through a system called a power divider. The truck can be moving at any speed and simultaneously pushing FOAM through its turrets at full pressure. The operator drives with one hand and manages turret controls with the other. There is no setup time. The moment the truck arrives in range, Agent is already in the air. Here is the part that tends to stop people cold when they first hear it. If a fire breaks out inside an aircraft cabin while passengers are still on board, and the crew cannot get everyone out before the interior temperatures become lethal, there is a weapon on the ARFF truck designed specifically for that scenario. It is called the Snozzle, formerly the High Reach Extendable Turret. It is a 65-foot hydraulic boom mounted on the roof of the truck, and at its tip is a hardened steel spear with holes drilled through it like a thick sprinkler head. The operator, working from inside the cab using a joystick, extends the boom, positions the tip against the aircraft fuselage, and drives it through the skin of the plane from the outside. Once penetrated, FOAM is pumped directly into the cabin interior. Passengers can still be evacuating through the exits, while the truck is simultaneously suppressing the interior fire from the outside. The first documented operational use of a piercing nozzle was in December 2003 at Memphis International Airport, when a FedEx cargo aircraft experienced a landing gear collapse and deep-seated cargo hold fire. The piercing nozzle accessed the fire in a location that handlines could not have reached in time. If you find this interesting, subscribe for more breakdowns like this one. The enemy in all of this is not just the fire. It is heat transfer. A jet fuel fire burning on the runway can produce radiant heat intense enough to ignite secondary fuel sources and degrade the aircraft structure from a distance of several feet, even if the flame is not in direct contact. This is why ARFF trucks can activate nozzles mounted underneath the chassis that spray FOAM in a full 360-degree circle beneath the vehicle. If a truck has to drive through a burning fuel pool to reach the aircraft, those under-truck nozzles create a protective envelope of foam around the wheels and undercarriage to prevent the vehicle itself from being disabled mid-approach. The truck is designed to drive into fire. The cost of this capability is significant. A fully configured Oshkosh Striker runs between $600,000 and $800,000 per unit. Large commercial airports do not operate one. They operate fleets, positioned at multiple stations around the airfield so that no runway is ever more than 3 minutes from response. Beyond the vehicles, airports invest in continuous training, foam inventory, and certification requirements that are audited by the FAA under Part 139 of Federal Aviation Regulations. Failure to maintain ARFF compliance is one of the few violations that can result in an airport losing its operating certificate entirely, meaning no commercial flights. The stakes of maintaining the system are not just financial, they are existential for the airport itself. The next evolution of the ARFF truck is already in service at a handful of airports. Oshkosh introduced the Striker Volterra in 2021, a hybrid electric version of the Striker that reaches 50 miles per hour in under 25 seconds with significantly lower emissions and noise. Dallas-Fort Worth International Airport ordered 6 of them. The electric drivetrain eliminates the delay between pressing the accelerator and full torque delivery, which means the Volterra actually accelerates harder out of the station than a conventional diesel model. The foam systems, turrets, and snozzle are identical to the standard Striker. The mission has not changed. Only the powertrain has. So next time you are sitting on a plane waiting to push back, look out the window toward the far end of the runway. If you are at a major commercial airport, somewhere in that distance there is a lime green truck sitting in a bay with its crew ready to move. They know the layout of every aircraft type that operates at that airport. They know the fuel load. They know the fastest route to the farthest point on the runway. And they are sitting there not because something is about to go wrong, but because the entire system of commercial aviation depends on the assumption that if it does, 90 seconds is all the time there is. Those trucks are the reason that assumption holds.